In this video, I'm going to try and provide you with a few things you should consider before removing an interior wall or making an opening larger. I think the year 2016 was a record emails. I received lots of emails from people doing this, and I imagine it's a common thing or a popular part of remodeling, and did this a lot when I was doing a lot of remodels. Let's start out with a basic understanding of a load-bearing wall. A load-bearing wall is a wall that is supporting something above it. It could be the ceiling joist, and it could be a roof rafter, could be a beam, could be supporting some type of another section, an upper floor. A lot of things that a load-bearing wall can support. So the weight actually gets transferred from the upper framing members, ceiling joists, roof rafters, posts, beams, down through each individual stud. And in a situation like this, it's going to be more equal. The weight of the joist is going to transfer down to the stud. Each individual stud is going to pick up a certain portion of the load above, and this isn't going to be the same once we remove some of these studs and put a beam in there. It's going to actually transfer around the beam. That weight eventually will transfer down to the floor framing joist. So here you can see that the weight is going to be equally distributed. Each individual stud is going to be distributing the weight a little more evenly than it will be once you remove a few of these studs to install your opening. That weight is transferred to the beams, the supporting beams, and this could actually create a problem also. Well, as you can see here, that each individual stud is to get transferring weight more evenly throughout the floor, and it's getting transferred to the beams that are supporting them, and then of course down to the footings. Let me back up here, down to the footings. So the weight transfers. Main thing I wanted to leave you with here is an idea of weight transferring on a more equal or even being evenly distributed than if you create a wide opening. Then you could actually end up with a concentrated load on a framing member that was not designed to support that load. So again, here's where the weight would transfer down to the piers or the foundation and then down to the ground. Here's a small opening. This is standard. You're going to have a doorway. It might be 3 foot wide, something like that, 3 foot or less. And this isn't going to create a big problem for a floor like this. The weight's basically, you're talking a small area. It's only the weight of an additional joist. I say that, but if there's a concentrated load above this, it's totally different. Let's just say that there's a post above here, and this is a larger header, then there's a good chance that the framing members will need to be larger on the bottom. And this would also be a problem if you did it. Let's just say that you didn't have an opening. You wanted to put a doorway in, you wanted to build something, but right above it you had some type of a heavy load that the wall was supporting. Then you might need to do something a little different here. Now remember, keep in mind, I am not a structural engineer. I know that some of you get tired of me hearing that, but the truth is I'm just providing you with information I have actually gathered over the years by working on projects. So these would be projects that I actually worked on, remodeling, repairs, even new construction, where I have a general idea of how this stuff is actually assembled. So the weight here would be transferred down in this area. Anything right over this, where the header is going to actually be transferred to the other side, hopefully evenly, and the header should be designed accordingly to the weight that it's going to be supporting. And you might actually need to put double trimmers or even posts depending on how much weight is going to be supported. And again, if you're getting into, if you have If you're just going to be digging into a wall like this, and single-story home, truss roof, or conventionally framed, where you don't have a lot of weight, it's pretty much equally distributed throughout the house, installing a door like this might not be a problem. Installing a larger opening, of course, is totally different. So you can see here that the weight is being transferred down to these framing members. And the framing members here, if I was just to draw kind of a square here, something like that, you know, the weight on this right here is some of this is being picked up by some of the nearby joist. So, but the bulk of it is going to be supported by the nearest joist, which on larger openings definitely will require additional support. Okay, here's a larger opening, and I'm going to go a little faster on this part. You already got a basic idea. Load on this opening is going to be transferred down to a larger area. A beam, the longer the supporting beam is, the larger it's going to need to be to carry the weight. And on openings larger than 5 foot wide, you are going to need to have double supporting trimmers. So here you can actually see where the weight is being transferred. There's going to be more weight being transferred to the same joist. So if we have a smaller opening, the weight's going to be transferred to the joist. It's going to be less weight being transferred the smaller the opening. So you might need to actually install a double joist. You're going to need a double joist underneath them or some type of a support. Larger openings are going to require, and this is the problem I'm starting to see. I mean, people are just going in, they're ripping out the wall, they're putting a beam in there, and they want to be able to look through the living room into the kitchen. I understand that. But with something like this, by now, hopefully you understand that now we're supporting a lot of weight. A larger beam like this, a larger opening, is going to be supporting all of the weight from the ceiling joist and the roof rafters above, and it's going to be transferred down, creating a concentrated load on the floor joist. And that's going to require an additional pier. You're going to need to pour some concrete, put a footing underneath this with some type of a post, something to support it, to distribute the weight right from the double trimmers or right from the post, whatever you're going to use above, down to the foundation, down to the ground. This is just a must. And when you say how large of an opening, for me, it would all depend on how much weight is going to be supported above. If it's a non-bearing wall, you might not need anything. If it's a load-bearing wall, depending upon the weight, you might need to install a double floor joist. You might need to install a floor beam, something larger with a larger footing. You might actually need something larger than something like this. So, and again, I'm providing you with two different examples here. This, we installed another joist, a post, a strap, and a footing. The other one, we just ran the post all the way up. So again, something like this needs to transfer down to a heavy-duty framing member if it's going to be supporting a lot of weight. Now let's take a look at a wall that would run parallel to the joist and have a supporting framing members or supporting framing members underneath them. Now I would like to point out that if you have a wall like this and you see the double joist, it might be a non-bearing wall above. It's common framing construction to install double floor joist underneath walls that run parallel. You can actually block the walls. I think it's 16 inches on center. You can install blocks in between or underneath the wall also that would run perpendicular to the wall. So, but this is a common practice. This is not going to suggest that you have a load-bearing wall above. It will not. Common framing for both non-bearing and load-bearing walls. Now, if you come across something that's got a heavy-duty beam or something underneath it, then you might want to make sure that you do some research above to make sure that it's not supporting more weight. So the double framing member, the load is going to transfer from the wall and the opening above down to the beams on each side the same way as it would if they were running the other way, except that this is a concentrated load. I don't want to suggest this is a concentrated load, but by installing the framing on top of the double joist, then you are putting the weight of the entire wall, let's put it this way, is on this doubler. When the wall is running perpendicular to the joist, then it's going to be a little more evenly distributed along each joist and then transferred to the beams and down to the foundation. So this right here, I think you can actually go a little farther. You can put the openings, the entire opening, the weight of anything that's above here is basically going to be transferred to the entire floor joist or the double joist. So by moving by creating an opening and eliminating some of the studs, and this is just my personal opinion, the weight is still coming down and being transferred to the doubler and off to the side. So the only thing you'd be losing here would be the lateral strength with the openings, and I'll go into that here in a few minutes. Now, a larger opening like this could actually be a problem. And remember, I'm not an engineer, so I'm not suggesting that it will be, just based off my experience. If you go more towards the center, if you concentrate the load more towards the center of the floor joist, which you can see right here, the opening is both sides is near the middle of the floor joist and not the edges, then I think you could be putting more stress on framing members that might not be designed to carry that load. So let's just say I got a line here in the middle, and then I divided these up into quarters. So 1/4, half, 3/4, and a whole. The load that's closest to the center is actually going to put more pressure on this framing member than a load placed on either side, or the closer you get to where it's being transferred. So if the load is right here, it's kind of like it doesn't have very far to go. Not going to be a lot of pressure. If it's in the center, near the center third of the floor joist, let's say, then you might be putting too much weight by installing a wider door. You might be putting too much weight on the framing members, and if this is the case, you're going to need to install a beam or something underneath it. And the reason why I'm making this video, like I said, is that a lot of people just go in and they install, hey, I'm just going to remove the wall studs, and they don't think about what's underneath. And this is actually going to be a problem, I think, if it isn't already, as people just keep on removing the wall framing and thinking that that it's not going to be a big deal. So keep that in mind. Now, the next part of the video is going to be on the lateral strength or side to side that could be affected by creating these openings.